Hey guys, how you doing today? So what we're going to work on is surface areas of cylinders today. So last time we talked about surface area of prisms, and cylinders are the next logical step. I just want you to look at this real quick. This talks about exterior angles of polygon. I don't really care about that right now. What I'm concerned about is you just looking at the shape right now. This is a triangle, so it has three sides. Now we go to a pentagon or a quadrilateral pentagon. Now these all happen to be regular ones, so they're all the same angle, same side lengths, congruent side lengths. So 6, side 7. Now what I want you to notice is as I add more sides, doesn't it look more and more like a circle? Okay. I mean, I'm up to 41 sides right now, and it looks almost like a perfect circle. Okay, now I can keep going and going and going and going and going and going and going. And the more I go, the more or the closer that the polygon's going to be, or the prism is going to be to become a cylinder. Okay. So a cylinder is just basically a special kind of rectangular prism. I'm sorry, just a prism, straight prism. Okay. So we're going to think about, in order to find the surface area of this, we're going to think about a tuna can. Okay. So I enlisted the help of my daughter to help us out.
Look at the tuna can. Notice that there's a label. The label is a rectangle. The height is the height of the can. But can we find out the length without measuring it? It's the circumference of the tuna can.
And that is what we are going to be using today to find the surface area of a cylinder. Okay. So how do we find the surface area of a cylinder? It's actually really not that complicated. All right, so just like we did with the prism, you have two bases, right? In this case, the base just happens to be a circle. So to find the area of a circle is not that complicated. You know that. It's pi r squared. All right. Now, what's different now is instead of having lateral faces and each lateral face being connected by a rectangle, this whole circular part is actually a lateral face. And if we were to cut it open, just like we showed on the tuna can, it's actually a rectangle. Okay, so the dimensions of it are the height is the width, and the length is the circumference of the circle. So we know the circumference of a circle is 2 pi r, or it's pi d. Okay, so the area of the lateral face is going to be the circumference 2 pi r times the height, or pi d times the height, depending on which dimension you're given. Okay, so there are two different formulas we could use to find the circumference of a cylinder. Now, is it great to memorize this? Sure. Okay, but I'm under the impression I like to know how to figure it out. So yes, that's great to memorize, but think about, okay, it's the area of the base, pi r squared. We have two of them. And then this is the height times the circumference. So that's 2 pi r h or pi d h. And then you just add those two up, and you're good to go. Now, using the distributive property or factoring, I could change this. I could get a little bit more simplified. Whatever you want to do, doesn't really matter. Okay. So this is what the net of a cylinder is going to look like. Okay. So what we have is the base is 4 millimeters. And then we have the lateral face right here. So our area is going to be pi r squared for the top base, and then we have two of them, so top and bottom, and then we have the lateral face, 2 pi r, which is going to be the circumference, right? Because double the circumference, double the radius multiplied by pi, you get the circumference times the height, which is 3. Okay, so the base is going to be 4 squared times pi, which is 50.24. The lateral face is going to be the circumference, okay, 2 pi times 4 times the height, which is 3, and that comes out to be 75.36. So the surface area is going to be the sum of those two, so 54.24 plus 75.36, and that equals 125.6 millimeters squared. Now for pi, when we're multiplying it out, just use 3.14. Yes, you can use the pi button on your calculator. That's totally fine. You're just going to then have to do some rounding after it. We tend to go to the nearest hundredth. Now you're saying, Ms. Broad, why is there no hundredth there? You guys know why, because that added up to 0. So when that's a 0, we'll go to the 10. Okay. So now this question asks for us to find the lateral face. So the lateral face, again, is just the circular part here. It's not the top or the bottom. Those are the bases. So again, our formula is going to be the height of it times the circumference of the base. So in this case, they give us the diameter. So we're going to use the formula with the diameter, pi times d. And then we're going to multiply that times the height. So pi times 3 times 8 is 75.36 yards squared. Now let's bring it into some real life situations here. So the iced tea is made from the iced tea can, any aluminum can, all right, they're made from one solid sheet of aluminum. And it weighs 0.01 ounces per square inch. So that's very light for square inch. You receive 40 cents per pound of aluminum when you recycle. Or as they say in England, aluminium. How much do you earn for recycling 24 iced tea cans? It's a lot of iced tea cans. Okay, so we need to find the surface area of the iced tea can. Okay, so we start out with finding the area of the top and the bottom. So that's 2. So pi r squared is the area of the top. Multiply by 2, we get the bottom. And then the area of the lateral face, the circumference times the height. So we plug those numbers in. Okay, comes out to be 80.07 inches squared. Now that is the amount for one can. Okay, we don't have one can, we have 24 cans. So, oh, sorry, I jumped ahead a little bit. So what is the weight of one can? So that comes out to be the weight of one can. Now you don't have to do it exactly this way. You could have multiplied this by 24 and then multiply by that. Doesn't matter which way you do it. Okay, I just happen to multiply it by what does each can weigh, and then you multiply by 24, whatever. So each can weighs 0.8007 ounces. You multiply that by 24, and that tells you the total amount of aluminum. Now, is that going to give us the right answer? Not yet. I can't multiply that by 0.4 because this is ounces, that's pounds, so we now have to convert to ounces. I'm sorry, we have to convert the ounces to pounds, so we divide it by 16. 19.2 divided by 16 is 1.2 pounds of aluminium. Now we can multiply that by, oh, it's a little bit far down. There we go. Comes out to be 48 cents. 48 cents for the total thing. Okay. So good luck. Have fun. If you have any questions, reach out to me. I will have Gold Guardian on with the chat function open. Just let me know if you need any help. All right. Bye.